I think every flat Earth researcher has seen the DogCam high-altitude balloon videos. They're used a lot to prove the flat horizon. They're also used to prove a globe Earth, mainly because of ignorance surrounding wide-angle lenses and their effect on flat horizons. To find out if that footage represents a flat Earth or a globe Earth model, I animated each using identical camera movements. First, let's watch a little of the original. Things to look for: the presence or lack of hotspot on the surface of Earth, what happens to the horizon as it moves above and below the camera's center axis, and is there any motion parallax between the horizon and the sun as proposed by Rob Skiba. This hotspot on the surface of the clouds looks like a local phenomena, yet that would be impossible on the globe Earth or the flat Earth model at this latitude. This video was taken above the Tropic of Cancer. The only explanation I can see is that the Atmos plane itself is acting as a type of projector for a sun that is much higher, 3,000 or 4,000 miles up. And we are just seeing the image of the sun as it appears in the Atmos plane, 100 or 200 mile thick substance of water and gas vapor. Okay, that's enough for now. I will post the original link in the summary. Now let's analyze both models against the original.
Yeah, if you've seen the standard model right now, it shows the sun
the spiral,
shooting through the universe
and spiraling,
and and everything else spiraling around it as it's going out there. Speaking of the sun, there's all kinds of weird things about the sun when you start actually paying attention to it. And there is, speaking of high altitude balloon tests, one of the most famous ones on YouTube that everybody's probably seen by now is the dog camera. It's the DogCam. It shows the wing of a support structure that has a camera and there's a little banner on it that says DogCam. And it's probably using some sort of wide angle fisheye lens, but the horizon is pretty close to right across the center. So you're not really getting the distortion. And it's wobbling around a bit. But in several shots, it shows the sun. And right below the sun on the Earth is a hot spot. Like right below the sun. Well, the sun's 93 million miles away, and it's so much bigger than Earth, putting one big parallel lines of light toward us. How are you going to get a hot spot directly below it? And the other problem with that is it's shaking and it's moving. The camera, the picture is.
So you're getting rolling shutter.
There is zero motion parallax. Now, if you've ever noticed, if you've ever driven down a road like out in like in Lubbock, Texas, there's this area where there's lots of windmills. And nothing else. It's flat as can be. Windmills as far as you can see. And if you're driving, 80 miles an hour or whatever on the highway, you notice that the windmills are beside you, or the closest to you, they're whipping by.
Really fast.
But the ones further in the distance, the further out you go, they're hardly moving.
I think the question Rob had was if there should be motion parallax between the horizon and the sun. The distance to the horizon at 110,000 feet is 406 meters. The distance to the sun in their model is 93 million. I think the reason they had to put the sun that far away was to avoid any issue of motion parallax.
Now, if the sun is 93 million miles away, then when you see the movement that weather balloon is doing, and the horizon's coming in and out of frame and doing different things like that, there should be a notable difference between the speed at which the horizon is moving and the speed at which the sun, 93 million miles away, if there's motion parallax. There should be a difference.
Yeah.
The problem is they're in perfect sync. Perfect.
The horizon
sync.
and
the horizon and the sun are perfect sync in its movement, showing that it has to be a localized object. As localized as the hot spot and the horizon that's in the distance. And that was one of the first things that caught my attention when I saw them. Like, there's no motion parallax there. There should be considerable motion parallax with the Earth that close below you and an object 93 million miles away. There should be considerable motion parallax.
Now let's see how a swinging camera would appear on the flat Earth model. Same camera specifications and altitude as original. It doesn't look like there is any noticeable motion parallax between the flat Earth horizon and the local sun. Now let's see what the same exact camera movements look like on the globe Earth model. The sun does appear to move higher in relation to the horizon as it moves up to the top of the frame, but I think that is just due to the curvature of the lens where distortion will be the greatest. Now let's see all three together. In the next week or so I'll do another one of these comparing it to Rob Skiba's recent launch, and I will try to match the camera movements to the original as much as possible. In this case they are similar between the globe and flat, but the original is difficult to match as it has many cuts and edits.